Trig, what's up? This is Mr. Carlson. We are finally done with week 3 after this lesson. Awesome. So, trigonometric graphing, Desmos activity, that's what we're going to be doing today. You do have bell work, so we're going to go through that. You also have a homework quiz. We're going to go through that. And then the Desmos activity, fairly short and mainly just a review over everything that we learned this week with the graphing. And then you do have a focus note check. So make sure you do your focus notes and submit them on Google Classroom. Let's do it. 2 questions on the bell work. 2 times cotangent of x plus pi all over 6, and then tangent of x plus pi all over 5. That's what we got, okay? So how do I do this? Well, graph 2 periods of the given cotangent function, graph 2 periods of the given tangent function. So we're going to go straight to Desmos and see how we can graph 2 periods of what that is. I'm going to show you how to restrict it as well. So in case you forgot, you can restrict it and everything, and we can go from there. So 2 cotangent x plus pi over 6. Whoa. 2 cotangent x plus pi over 6. Let's go over here. So I'm going to go over to my cotangent. So 2 cotangent of x plus pi over 6. So that means my b is 1, and then plus pi over 6. So that means minus pi over 6 because I need to make sure I accommodate for that built-in negative. Okay, and I don't have any b or d value here. So my c value, if this kind of helps you, your a is 2, your b value is 1, and then your c value is negative pi over 6. That's what I have, okay? And I'm just plugging that into Desmos. Good deal. Now we want two periods, graph 2 periods. So one period is like right here. It's kind of hard to see. It's kind of like in the middle here because it shifts. Okay, we can find our horizontal shift if you wanted and everything like that, but we're not going to, but it's technically shifting like right there. Okay? Yeah. Definitely shifting right there. That's the middle point. It's really hard to see because we don't have it here. So if we just maybe took this, copied it, paste, this restricts it. So maybe we take off the pi's. Okay. Well, maybe not. So maybe we do 3 pi and then 3 pi. Well, that's a little bit more. All I need is 2 periods. So really, this is why it's very difficult to like graph because really can't get any better than this. This is pretty good. So this is 1 and this is 1. And so this is a little bit more than 2 periods, but this is actually really good. So as long as I have 2 solid like strokes right here, 2 solid branches, I'm solid. Okay, I'm good. But that's what it would look like. Okay, of course this is restricted right here. I'm trying to figure out what that value would be. Maybe in between that, so 3 pi over 4. No, definitely not 3 pi over 4. It looks close, but you get the picture. That's what it would look like. You have to sometimes play around with it. I could find where the asymptotes are if I wanted to. I'm not going to. We could do exactly what we did yesterday, and we could just do this. So if I wanted to find out where those asymptotes really were, it's just that bx minus c, and then this is pi for cotangent. And so I'm not going to graph them, but let's go ahead and find them just because. What's your bx? So this is your bx, so this is 0, x plus pi all over 6, and then pi. And I minus pi over 6 on either side, so minus pi all over 6. This is x. If I minus pi over 6 right here, this is 6 times 6. So this is actually 5 pi all over 6. Okay? So let's do that. Let's just, you know what, just for kicks and giggles, because this is going to be a short lesson, might as well. So negative pi over 6 to 5 pi over 6. Let's just do that instead of just guessing and checking. Negative 5 pi over 6, 5 pi over 6. Yeah, it kind of looks like junk, but that's also because this is where my asymptotes are supposed to be. These aren't really my restrictions. These are where my asymptotes are. So I didn't really think it would look too pretty. But, uh, this is how you find your asymptotes, and you can definitely plot this. Oh, that's my problem. Negative pi. So let's go back. Let's change it to that. Okay, so yeah, that makes a lot more sense because boom, your asymptotes would be somewhere around here. Your 5 pi/6 would be right here, and so yeah, it restricts it right here. But again, it doesn't show you your asymptotes, so it's not really that helpful. You can definitely like go down here and say x equals negative pi/6 if you wanted, and that's one asymptote. So that's great if you wanted to, but I'm not going to continue doing that. So you just have to mess around with it and then get the right graph. Math Excel is pretty easy when looking at the different graphs. You just look at it and then graph it on Desmos or graph it by hand, like what we did on the video, and then see which one it is, A, B, C, or D. I mean, seriously, it's that simple. Okay, awesome. So let's go to our next one. So again, I'm going to have A equals 1 here, B equals 1, and then C equals negative pi/5. And let's find our asymptotes. So my asymptotes are using this formula, and I'm going to plug in my B minus C value here, and then pi/2. So that's how you find your asymptotes. And then minus pi/5. So this one's a little bit more involved. Okay, so minus pi/5 on this side. This is x. Pi/2 minus pi/5. So, whoa, okay, so this is times 5 is 10, times 5 is 5, times 2 is 10, times 2. So this is 3, 3 pi/10. Nasty looking asymptote. I mean, for real. And then this would be pretty much the exact same thing. So negative 5 minus negative 2, so negative 7 pi/10. Wow. Yeah, really nasty. Yeah, I'm not going to graph those asymptotes, um, but I will probably use them for restrictions on this graph. So tangent x plus pi/5. Let's go over there. Tangent x plus 5 all over x plus pi/5. This is 1, and this was just pi/5. I got. Okay. If we wanted to graph those asymptotes, I had, or graph the restrictions, so negative 7 pi/10 and 3 pi/10. So negative 7 and then all over 3 pi and then 10. Boom. So you get just one branch, and your asymptotes are somewhere that are hidden there, but that's okay. Like, and if they want you to graph 2 periods of the pi, you can just add on an additional pi here. So you can just do plus pi, and then there's 2 periods if you wanted to. Even with your cotangent graph, if you wanted to actually graph 2 periods to see what it really looks like, you definitely could. You could do plus pi here. Why am I doing plus pi? Because I'm doing plus pi because remember, the cotangent and tangent graphs are um, undefined. They're undefined at certain values, undefined at every pi odd multiple of pi. So that means every pi value they're going to be undefined at every odd multiple of pi. So that means all you have to do, your period of cotangent and tangent is pi. All you have to do is just add pi on the end, and then boom, you get an additional period. If I wanted 3 periods, I would just add additional pi if I wanted. If I wanted another period, I would add additional pi, and that's 4 of them, and so forth. But right now, they just wanted 2 periods. So that's the first question right here. That's what it looks like. besides the asymptotes. I mean, that's what it looks like. And you can even see, where they're at. And then the second question is this one right here. Again, besides the asymptotes. So, not too bad. All right. So let's go back. Let's erase and get you guys started on the homework quiz. 5 questions, 25 minutes. Make sure it's open notes. Review your answers, send in partial credit requests, get started. And then afterwards, you can begin working on your weekend homework, which is Math at Sea. It's another Google Classroom discussion. So make sure you're responding to the questions. Respond to two other individuals. And so hopefully it is a very good discussion. Hopefully you guys don't all agree. That would be one thing. So hopefully you don't all agree there. Okay? So after you're done with the homework quiz, get started on the Desmos activity, the last Desmos activity for the week. So trigonometric graphing, it's really just basically exploring the range, the midline, and then the amplitude of trigonometric functions, just very informally looking at only sine and cosine graphs. So go to student.desmos.com, type in the code. Remember to do your notes. Okay, remember to do your notes on Google Classroom. Okay, due today by 4 p.m. That's not your weekend homework. That's due today by 4 p.m. Awesome. So let's go here. Again, this link is also posted on Google Classroom. So you can go on Google Classroom, just hit that Desmos link at the very end, and it'll take you right here. Okay, perfect. All right, so what are we going to be doing? Okay, so first off, we're going to be, again, exploring some range, the midline, and everything. So the shading helps us represent the range of the function. It really does. Okay, so this shading helps us represent the range. Our range should be right here. So if I move that orange dot, I should get that. And perfect. Once I'm done with that, I can move on to the next screen. Now, what it's going to ask you is to kind of rewrite the function because I was a little bit off there, as you can see. So I was just a little bit off, so I need to kind of go right here and kind of fix it. So boom, there, I fix it. Now remember, this is the same thing as interval notation. This is the same thing as 1, 5. Okay, and now notice also you have a y variable there because it's range. Okay, the domain is negative infinity to positive infinity, right? For interval notation, it's all real numbers. For set notation and so forth. But this is your interval notation for that inequality. Okay. Just to preview that, make sure you understand that. Okay, make sure you remember. And so then you're just going to go to the next one. You're going to try to write the inequality and do the exact same thing. So this is, what is it, from like the range 3 to negative 2. So I'll change this bottoms up. You're going to bottoms up, so negative 3, and then you're going to 2. I switched it up. This was actually negative 2 to 3. That's my problem. There we go. Okay, now what happens if you do 3 to negative 2? Nothing. You know why? Because it doesn't make any sense. You can't have a variable that's between 3 and negative 2 because it's not reading it left to right. So you need to make sure you're reading left to right, or in this case, because it's range, bottoms up. Okay, so you need to take this value right here, this bottom point value, negative 2, and then you need to change this to the 3, and then you'll get that. Okay, so bottoms up, left to right. We always work from the bottom, the negatives, all the way to the top, the positives first. So that one is pretty simple, just kind of reminding you about range, set notation, and so forth. So now you're going to write an inequality that correctly shows the range of this function. I'll leave that one to you, but again, just look at the top, look at the bottom, look at right here, negative 0.5, look at this, 2.5, and then develop an inequality that's very similar to the inequalities that we had here, okay? In this slide, you're just going to change it, so you're going to kind of slide it around. You're going to try to get this sine function to somehow be in between your range, okay? So do that. Very simple, just do it. Just kind of try to get it right in between the range, see if it gets perfect. That's so close, so then you have to mess around with it. Slide 6, you're going to just say how they relate. So some of your values on screen 5 are incorrect, obviously, because I didn't do it perfect. Hopefully yours is correct, and then you'll be able to actually say how do they relate, okay? We'll go to the next one, fix it, and you want this equation that tightly fits this shaded region. So if I actually submit this, it's not clear. So then I have to do some trial and error, right? So I have to kind of move some stuff up. So maybe what if I do, let's say plus like, I don't know, 8. That's pretty good, but I have a really big range to fill. So maybe I have to change this amplitude a little bit more. Okay, it's a little bit better. Okay, and so you have to kind of figure out how to actually fit that in. And the reason why I'm making you figure this out by hand is because it actually ties directly into what we call the midline. Okay, it's what we call the midline, and so you have to really pay attention. Like, what is this? This amplitude. Maybe if it's 10. Is that 10? Like, oh, that's pretty good. But if I move this up a couple more, I mean, wow, that's actually really good. But it's a little bit too short on this. So maybe I simplify this to be 8, and then maybe move it up 2 more. Okay, so you have to mess around with it just like I did here. Okay, same thing. Try to write, though, a trigonometric function. And this is the hard part. This is really hard. I'm going to leave this perfectly up to you guys. I'm not going to touch it at all. But try to write. I mean, what we did here was we pretty much wrote this trigonometric. We didn't write. Well, we kind of did. We kind of wrote this trigonometric function here. But we just messed around with the values. Here, you need to actually write down the values. Okay? So try to see what you did here. See where the midline is. This how is this -8? Okay, where is this at -8 right here? Even if it was +8, do I need to have a -8? What if it made it to a positive? Does it still fit? Okay, it still fits. So then try to figure out, all right, so where's the middle point? And then try to do that on this. Where's the middle point? Where's the half section? So then what's my amplitude? And then how can I kind of shift it up and down? Try it yourself, okay? This is just going to be predicting, and then this is verifying. And so the rest you'll be able to figure out, okay? And this is just a little bit more with domain and range. So that's all I'm going to do on this activity because I really, really want to stretch your brain to kind of figure it out. Remember, I want to try to see if this is going to be done by 4 p.m. If you can't finish it by 4 p.m., I'm okay with allowing it to go over the weekend, personally. So just let me know if it needs to be over the weekend. More than likely, I won't grade it until the following Monday. So finish it up though yourself, and then after that, please finish up your homework that is over the weekend, Math at C, and the Google Classroom discussion. I will try to get to your grades as soon as possible. I'll more than likely send out an email. I may or may not. Grades are posted because I'm updating it every day. I hope you learn new things about sine and cosine. Guys, this has been a great week, a hard week, I think, for me personally. If you watch my videos, you can probably definitely tell that is true. But it's definitely been a hard week for me. I've been very distressed and frustrated with the math and just being a teacher. So, I appreciate your encouragement, but you guys are awesome. So keep it up. This is C Squared Mathematics. I'll see you guys on Monday.